Welcome to the lesson video for Unit 7, Day 1, or Day 7.1. We're going to start this lesson. We're going to talk about area, composite area, and perimeter. Unit 7, we start to talk about surface area and volume of three-dimensional figures. So for this lesson, we're going to go back and review some area formulas of our basic simple shapes, and we're going to carry that into what we call composite area and see how we can use these formulas to find other calculations. So as a review, we should remember that the area formula for a circle is pi r squared. Whatever the radius is, square that, multiply by pi. Then we're actually I'm going to skip around a little bit. Let's talk about a rectangle next. And again, most of you probably remember the area of a rectangle is just length times width. Whatever the length is, one dimension horizontally times the other dimension vertically, we call that length times width. Now, what I could do here, I could take this rectangle and kind of take and cut a corner off. If I take that corner and I move that corner over here, I get this shape, okay, which ends up being a parallelogram, okay? Looks like this. Again, it looks like I've taken the corner from a rectangle, cut it off, move it over to the other side, and we get this. So it really has the same area, nothing really reduced. So the area is still this dimension by this dimension. Well, instead of length and width this time, we're going to call the left and right dimension the base, and the up and down measurement the height. Okay, base is B and H is height. All right. You'll notice base and height always form a right angle with each other. Okay, that's another thing to remember, that the base measurement is always perpendicular to the height measurement. But this is your area formula for a parallelogram, base times height. We do want to go back over here and talk about squares as well. Square is kind of a special kind of rectangle where the length and width are both the same length, so we call those side. If I end up doing S times S, that's the same as doing side squared. So the area formula for a rectangle is S squared. Okay. All right, so there's a couple other ones we want to talk about, and the first of those is a triangle. Now, a triangle has these same dimensions, base and height, and I want you to look at this example down here. Let me get rid of those. If I look at this parallelogram, and if I were to take this top corner up here and cut diagonally down to here and get rid of that shape, I get a triangle. Well, the area isn't going to be the same as just base times height because now I only have half of that parallelogram. So the area formula for a triangle that uses base and height is 1/2 base times height because it's half of the parallelogram that we originally had. Now, there is another way you could write the area formula, and another way I'll accept when it comes to memorizing these. At the end of Unit 7, you will have a formulas test again as part of your overall test. Another way we could think of this is you take the base times the height and divide by 2. So when we take our base times height and multiply by 1/2, that's the same as dividing by 2. I'll kind of accept either one of those. But you need to remember that base and height are the two measurements that touch the right angle, or they form the right angle. Base is always perpendicular to height. You'll notice the base has to be a side of the triangle, but the height is the distance from that side to the opposite angle. Okay, so the height is usually not a side of the triangle unless it were just a right triangle. And then finally, we want to talk about a trapezoid. Now, in a trapezoid, there are two sides that we call bases, and they're different lengths than each other. And these two sides we call base 1 and base 2. Since there's two different sides, we are still kind of using the idea of a base times a height measurement, but since there's two different sides, I'm going to take the average of those bases. Now, to find the average of two things, remember we add them up. So I'm going to take base 1 plus base 2, and I'm going to divide that by 2. I'm going to take the average of those bases times the height now. Height is still this perpendicular distance between the bases. Now, This is not the way you'll see the formula in the back of the notes. This is another way you can memorize that formula, but the way that it shows you in the back of the notes, instead of dividing by 2 like that fraction, we put the 1/2 in front. And instead of immediately doing the parentheses b1 plus b2, we put our h next, then the parentheses b1 plus b2. You're doing the same calculations, it's just a different order of writing them. And you can memorize either one of these formulas, and that's fine. A lot of times I will use this top formula in my calculations, even though I memorize this one. But again, the important thing to remember about this one is that the height must be measured at a 90-degree angle from the bases. Okay, we always have that right angle to one of the bases, making that the height. So those are your area formulas for these simple shapes. What I want us to do now, we're going to go through some examples. I'm actually going to have you pause the video here, and I'm going to have you do number 1, 2, and 3 on your own. When it comes to number 2, I do want you to realize this shape is a parallelogram. This is the actual shape. Not these dotted lines out to the side. These dotted lines are not part of the shape, but that just tells you this should be the height. I'll give you that part. The height of this parallelogram is 6, because I could just as easily draw that inside the parallelogram as well. Okay, so if I put the height measurement of 6 in there, then it's easier to see what the base should be. So again, pause the video here to try and do these problems on your own. And then when you think you're done and want to check your answers, click play. All right, these are the answers we should have. For number 1, we should have an area of 54. Okay, if I think of the length as 9, the width of 6, when I do area of a rectangle, that's length times width. 9 times 6 is 54. If we were doing units of measure, we would call that 54 kilometers squared, because you're doing kilometer times kilometer. For number 2, like I said, the height of this parallelogram is actually 6. So when I do the height 6 and the base perpendicular to that would be 7.1. 7.1 times 6 is 42.6. This would be in inches squared if we were doing units of measure, but you don't have to enter that part in Canvas when you do your homework checks. And number 3, on this triangle, the formula for a triangle is 1/2 base times height. Now the base and height, again, form the right angle. So I know my base is 8, my height is 3. So I'm going to do 1/2 of 8 times 3, which would be 12. Okay, so let's try the next 3. On this next one, number 4, this is a circle. I need you to remember the area formula for a circle. Area is pi r squared. If you look at this, you should remember from the last unit, this is actually the diameter. So the radius is 1/2 of that, which would be 11. So I'm going to do pi times 11 squared. Now, this problem asks you to give your answer 2 ways. One in terms of pi and rounded as a decimal. In terms of pi, all that means is I'm going to do the 11 squared, which is 121, times pi. And I'm just going to write it as 121 pi. You put the pi afterwards. Okay, and if I actually multiply by pi there and do 121 times pi, 121 times pi, I get 380.1. Okay. Number 5 is a trapezoid. So we need to start with the area formula for a trapezoid. The area of a trapezoid, if you think of it that first way I showed you, we're going to do the average of the bases. So I'm going to do b1 plus b2 all divided by 2 times the height. Now the base 1 and base 2 can really be either of these two, 3.2 and 12. So it doesn't really matter what order I put that in. I'm going to do 3.2 first plus 12, but I have to have it in parentheses. All over 2 times the height, which is the distance between those bases, 8.4. When you enter this in the calculator, you have to use the parentheses or do it one step at a time following the correct order of operations. I would encourage you to just put it in the calculator like this. Parentheses, 3.2 plus 12, then close the parentheses, then do times the 8.4 for the height, and then divide by 2 at the end. Now, you can actually do divided by 2, then times 8.4, and it'll still work. But we should get 63.84 for this answer. So the area here, and I missed some blanks, is 63.84. Our height was 8.4, base 1. We called 3.2, so base 2 is 12. Those two can be switched, that's okay. But we do get 63.84 for that answer. All right, last one together here. This is a square. Area of a square is just side length squared, and the side length is given to you as 6.8. So we're going to do 6.8 squared. If I do 6.8 to the second power, or squared, I get 46.24. Now, we don't need to round these because these are what we call finite decimals. They stop. Okay. So those are some area calculations with simple basic shapes. When we go to the next page, we're going to do some other calculations with those area formulas, but now we're not going to find area as an answer. We're going to start with area and work backwards and find something else. So on number 7, I don't even give you the picture, but in the problem, I tell you enough information for us to get started. We're going to start with the trapezoid area formula. When I'm using a trapezoid, my area formula is, again, you can write it 2 different ways. I'm actually going to write it the other way to show you it still works this way. 1/2 times height times the sum of the bases, base 1 plus base 2. I'm going to use that formula all based on the word trapezoid. But this time they tell you it has an area of 29.5, so that's my capital A. It has a height of 5 yards, that's your H, and it has one base measuring 8 yards. That's for, that could be B1 or B2, it doesn't matter. I'll call that B1. Okay, so if you're keeping track, A was 29.5, H was 5, and I'll say B1 is 8. So B2, I'm just going to call that X. I'm going to look for X here. So I'm going to plug these things in now. So instead of A, I'm going to write 29.5 equals 1/2. Instead of H, I'm going to put 5. And instead of parentheses B1, I'm going to do parentheses 8 plus, instead of B2, I'll write X and close your parentheses. Now, when you go to solve this equation, it's really important that you do things in the right order. Remember, 8 plus X is not 8X. Okay, 8 plus X, I can't combine. They're 2 different, they're not like terms. So the first thing we actually want to do is get rid of that 1/2. And to get rid of a fraction 1/2, remember, that's the same as dividing by 2. So we cancel that by multiplying by 2 on both sides. All that does on the right-hand side of this equation is cancels with the 1/2. So those go away. So my equation now, when I multiply the left side by 2, starts with 59. 29.5 times 2 is 59. So I get 59 equals 5 parentheses 8 plus X, because the 1/2 and the 2 canceled. I don't distribute the 2 in. I don't do 2 times 5. It cancels with the 1/2. Now I'm going to do things a couple different ways. What I would probably do first is distribute the 5 to both of these. And so my equation turns into 59 equals 40 plus 5X. And now we should see the next thing is to subtract 40 from both sides. 59 minus 40 is 19. So 19 equals 5X, and the next part of this would be to divide by 5. If I divide by 5, then X, or the other base that I'm looking for, would be 3.8. Okay, so we can use formulas to work backwards here. So what I want you to do, number 8 is a very similar problem, but this time we're talking about a triangle. I want you to start with the area formula of a triangle, plug in your information, work backwards to find the measure of the base of the triangle. So you're going to pause the video here, try this one on your own. If you need more time, pause again, but this is what we should get. We should get a base of about 9.0. It's actually 9.0196. You'll see in my calculator there. So we just round that to 9 or 9.0. I'd take either answer. Because we start with an area of 23, so I use this formula first. Area equals base times height over 2. The first step, once you plug in the 23 for A and the 5.1 for H, is to multiply both sides by 2 to cancel that over 2. So you get 46 equals base times 5.1. So we just divide by 5.1 and we get 9.0. Okay. All right, now we've talked about area now. One other measurement we want to include in this lesson is the measurement of perimeter. To find the perimeter of any shape, all you have to do is add all the sides together to get the total distance. The perimeter is the sum of all the sides of a figure. So we can use that in these calculations. So we're going to start number 9 with the given area. They start with the area. We're going to start with that, but we're going to work backwards and find the individual side length of a square, because that's what we're working with as the shape of a square here. But once you know the side length, we should be able to find the perimeter. Okay? So even without a picture, we know from the formula that area equals the side length squared. So our given area here is 400. So I plug that in for my A. Well, I can find the value of S here by taking the square root of both sides. To cancel out S squared, we do the square root. So my side has to be the square root of 400, which is 20. Okay, so my area was 400. That led me to figure out that my side length was 20. And if a square has 4 sides, remember they're all the same length, they're all S's, my perimeter is that side length times the number of sides there are, that'd be 4. So I'm going to do 20 times 4, which is 80. So the perimeter is 80 when this area of a square is 400. On number 10, we're going to kind of do the same thing, but this time instead of a square, we're going to use a rectangle. It says find the perimeter of a rectangle where the area is 400. So I'm using the same area, but it's a rectangle this time, which is why they go ahead and give you one of those dimensions. They give you the length. So I'm going to start with my area of a rectangle formula, which is length times width. I know length here. I know length is 25. I also know my area A. So I replace the capital A with 400. I replace the L with 25 for length, and I can figure out what the width is now. That width is going to help me find my perimeter because I need to know length and width to find the perimeter. So this time we're not going to do a square root. We're going to cancel out times 25 with divided by 25. So we do that to both sides. And 400 divided by 25 is 16. So I've got a width of 16 and a length of 25. If you think about the shape of a rectangle, there are 2 sides that we would call length and 2 sides we would call width. So your perimeter is always 2 times the length plus 2 times the width for a rectangle. That's going to be 2 times 25 plus 2 times 16 now, or 50 plus 32, which is 82. So a little bit different perimeter when I change this to a rectangle, even though they have the same area. Okay. So that kind of rounds out our discussion on these simple shapes, but we do have other shapes to work with, and those are any other polygons. We've so far only done the areas of triangles, rectangles, squares, parallelograms, trapezoids, and circles. Other than circles, these polygons we've been using have either 3 or 4 sides. Well, when you start adding sides and get things like pentagons, hexagons, octagons, that changes the way we find the area. So the first thing we're going to look at here is how to find the area of a regular polygon. Regular polygons, remember, have equal sides. That word regular means all the sides are equal. So this is the formula we're going to use to find the area of a regular polygon. I'm going to write the formula, and then I'm going to explain what these pieces of the formula are. So the area formula for a regular polygon is capital A equals 1/2 lowercase a times capital P. Now that lowercase a is a different measurement, okay? The lowercase a here stands for the word apothem, A-P-O-T-H-E-M. Okay, and I've given you a picture to show you what the apothem is. The apothem is a segment from the center of a regular polygon drawn at a right angle to a side of that polygon. So it's this segment here. It's kind of like a radius, but instead of going out to a corner, it goes to a side at a right angle. Okay, this would be your side. This is that lowercase a standing for the word apothem. Okay, So that's what the lowercase a is, and I will usually give you that number to use. A lot of times it'll be a decimal. But then the capital P, you probably know, stands for perimeter. Okay, and remember, perimeter is just the sum of the sides. Now, here's how we're going to calculate perimeter. If I know the number of sides, so let's say n is the number of sides, and s over here is our side length, the perimeter is that side length times the number of sides. Okay, so we can use that. Now, there's another way to think of this area formula, kind of like with triangles and trapezoids. Instead of thinking of it as the 1/2 in front, you could think of it as that little a apothem times perimeter, all divided by 2, like that. You can memorize the formula either way, and they still work. They're equal to each other. So let's do an example or two. In this problem, we need to start with identifying the number of sides, and you can do that by counting. We're going to start with n equals the number of sides. Well, we just count. 1, 2, 3, 4, 5, and 6 makes this a 6-sided polygon or a hexagon. Let me write that somewhere else. Okay, it's a hexagon. So if the number of sides is 6 and each side length down here would be 22, then I can find my perimeter by multiplying those two. I take my side length 22 times the number of sides, and I find the perimeter first because my area formula needs capital P. I need perimeter. 22 times 6 is 132. Okay. And so my area formula means I'm going to take that apothem, little a, which is 19.1, times my perimeter and divide by 2. So that's 19.1 times the perimeter 132, all divided by 2. When I do that calculation, I get 1,260.6 for the area of that hexagon. Okay, so this formula is what I use. That formula gets me this answer. Let's try another one. Actually, I'm going to have you try this one on your own, but I'm going to help you get started. Okay, the first thing you do on this one, number 12, is identify the number of sides. Okay, if you count those up, there should be 9 sides. Then you want to identify the side length, which is there. That's 10. And you want to use that to find the perimeter. Once you know the perimeter, then you're going to plug into your area formula, little apothem A, which is 13.7, times the perimeter divided by 2. Pause the video here, try and do those calculations, and then check your answers. All right, if you need more time, keep the video paused. Otherwise, this is what we should get. The perimeter ends up being 90. So if I do 13.7 times 90 divided by 2, I get 616.5. Okay. All right. I'm going to quickly show you these. If you want to pause this and try and do these two, you can, but I'm going to show you what the answers should be for the sake of time in this video. And then we're going to move on to the very last part of our lesson. Okay. Again, here are the answers we should get for 13. For number 13, the word nonagon means there are 9 sides. Make sure you understand that part. That helps you get that answer of 287.64. And number 14, a pentagon has 5 sides. So that's going to help you there. Okay. So as we move on to our final topic, we're talking about composite shapes. The word composite here just means shapes that are made up of basic shapes that we put together. The word composite just means put together. So if I'm just putting pieces together, the composite area is found by taking the individual areas or the areas of individual shapes and adding them together. This comes from the idea that part plus part, don't need the parentheses, part plus part equals whole. We've been doing that kind of all year. Now, there are some examples like you'll see on 17 and 18 down here, where it's not that I'm putting pieces together by sticking them together and adding, but I'm taking a bigger picture and cutting out a piece. Well, that leaves a shaded region. So to find the area of these shaded regions, we're going to find the area of that outside total figure and we're going to subtract the unshaded part. Okay? So let's go through these examples. For number 15 here, this is a composite figure. I'm sticking two pieces together. One of those pieces is this rectangle on top. The other piece is this trapezoid on the bottom. So my overall area is going to be the area of the rectangle plus the area of the trapezoid. So I'm going to split up my work here. The area of the rectangle, the area formula for a rectangle is just length times width. Well, that would be a length of 23 and a width of 12. Okay, if I do 23 times 12, I get a total area of 276. And I'm going to add that to the area of my trapezoid. Now, the trapezoid looks a little confusing because I haven't given you a lot of information. I've got a base 1 here, but I didn't write base 2 and I didn't write the height. Now, this would be my height. All right. Now, that is going to translate to part of this 18. Not the whole thing, but it's part of that length of 18. So that's what I'm going to use to find that is I'm going to use the 18, but I'm going to subtract this much from that. Well, that is my length of 12. It's that width of the rectangle. So if I do 18 minus 12, that gives me a height of 6. So the height of my trapezoid is 6. And the other base of the trapezoid is just this opposite length of your rectangle. It's also 23. Well, now I have enough information to work with my trapezoid. My area formula for a trapezoid is where I take the bases and I add them up, divide by 2, and multiply by the height. Well, base 1 was 15, base 2 was that 23, and then the height was 6. Okay, if I do that calculation, I get a total of 114 for the area of the trapezoid. So there's the two pieces I need to add together. So my overall area is going to be found by taking 276 from the rectangle plus 114 for the trapezoid. And if I do that, I get 390 square centimeters for the overall area. Okay? For number 16, we've got a few more pieces to put together. And this one can present a little bit of a challenge. But we're going to start by identifying those pieces. One of the shapes we're using is just a rectangle. I've got a length and I've got a width. I can find the rectangle. The other piece I'm using is a triangle. I'm going to do 1/2 base times height. Now, I'm going to assume this is a right angle. That makes this the base of that triangle and this little red segment the height of that triangle. This bottom portion is actually what we call a semicircle. It's half of a full circle. So I can find the area of those individual pieces and add them up. So we're going to start with our rectangle. The area of a rectangle, again, is just length times width. The shorter segment on top, that 9, we're going to use that as our width. So I've got to do something times 9. To find the length, though, I would look here, but there's no number written there. But it is part of the full 26. So what I need to do is take out this missing piece from the 26. So I've got to do 26 minus whatever that is. Now that is this distance from right there down to here. Well, you should recognize that's the radius of that circle. But the radius isn't just a vertical measurement. The radius also goes from the center to any point on the circle. So from the center out to the point on the circle here is also the radius. No matter which way I draw that, the radius ends up being this width of the rectangle, 9. Okay, so that's the number. This 9 is what I got to take away from 26 to find the length of my rectangle. 9 minus 26 is 17. So that length of the rectangle is 17. Okay, kind of tricky to find that, but I have those measurements now. So if I do 17 times 9, I should get 153 for the area of the rectangle. So that's one measurement I need. So let's move down actually to the semicircle first. Then we'll come back to the triangle to finish this up. For the semicircle, the reason I want to go ahead and do that is because I have the radius now. The radius of a semicircle, okay, imagine if it was a full circle, it would still have the same radius. We're going to use that to find the area of a semicircle. A semicircle is half of a circle. So I can take the area of a circle, pi r squared, and just divide it in half, divide by 2. So I'm going to take my radius of 9, square that, and multiply by pi, and divide by 2. And I'm going to allow us to go ahead and write that as a decimal. If I do pi times 9 squared and divide by 2, I get about 127.2 for the area of that semicircle. I've got one more part in order to put these things together. The other part is the triangle. Area of a triangle is base times height divided by 2. Well, the base and height of the triangle are over here. Now the base, you'll notice, you should notice now, that is the same as the radius of the circle. That's 9. So I'm going to do 9 times the height. The height is not 9. I've got to find the height. To find that height, that is lined up with part of the rectangle. The length of that rectangle is 17. So I'm going to take 17 and subtract this little 7 amount out of that. And I get 10. So the height of your triangle is actually 10. If I do 9 times 10, that's 90. Divide that by 2, and that's 45. So the area of that triangle is 45. So I'm going to add those 3 pieces together to find my total area. I'm going to do 153 plus 127.2 plus 45. And I get a total answer of 325.2 for that composite area. All right, let's go ahead and take a look here at these next 2. All right. Number 17 is actually pretty straightforward. These are shaded region problems where I'm actually going to take the overall area and subtract out a missing piece. So I'm going to take this 17. For number 17, the overall shape is a rectangle. Area is just length times width, and I have both of those. There's my width, there's my length, or vice versa, it doesn't really matter. I'm going to do 25 times 14, which is 350. And I'm going to use that to subtract out the area of this triangle. The area of a triangle is 1/2 base times height, or base times height divided by 2. Now the base and height are always perpendicular, so we're going to look for the right angle. The right angle's there. That makes this 11 the height, and this side the base, which is the same as the length of the rectangle, 25. So my base is 25, my height is 11, and I need to divide by 2. So that area of the triangle becomes 137.5. So the overall area of the shaded region is going to be 350 minus 137.5. And I should get a total area of the shaded region then, 212.5. Okay. So we've got one more example to do, and this one's going to be a little tricky to get started because it looks like we're missing a piece, and I'll show you where that is and how to find it. The overall shape we have here is a trapezoid. Okay. We're going to work with this trapezoid first, and we're going to subtract this semicircle. Okay. But let's look at the trapezoid first. To find the area of a trapezoid, we do base 1 plus base 2 all over 2 times the height. Well, base 1 and base 2 I've got. Here's base 1, there's base 2. So that's going to be 17 plus 37 all over 2, but I've got to multiply by the height. The height I could think of as this segment here, but I don't have that drawn. So I need you to realize that segment, even if I slide it over here, is still the height. And actually sliding it over there helps you see that I've got this right triangle over here. That's going to help me find that height measurement. because the height of that trapezoid actually ends up being a side of a right triangle. And in order to find the length of a side of a right triangle, I can use the Pythagorean theorem. A squared plus b squared equals c squared. Where that's why I give you this 25. That's the hypotenuse of that right triangle over there, C. And A is my height here. So I'm going to call this side B this. Now to find side B, I'm going to take my total 37 and subtract this amount, which is the same as the opposite side there, 17. So that side's a 20. So I'm going to use that for B. And this is A. So instead of A squared, I'm going to write H for my height, H squared plus B squared is now 20 squared, and C squared is 25 squared. I'm going to kind of quickly go through this. All right, 20 squared is 400. 25 squared is 625. So I'm going to do minus 400 from both sides. That means H squared is 225. And if I do the square root now, that height measurement is exactly 15, which is very nice. That works out really well for me. So the height of my trapezoid is 15. Now I can find the area of the trapezoid, okay? So if I add those together, 17 plus 37, divide by 2, multiply by 15, I should get a total area of the trapezoid being 405. But I've got to subtract the area of this semicircle. Well, the area of a semicircle, remember, is pi r squared divided by 2. The radius of that semicircle from here up to here, okay, this radius here is half of your 15, or 7.5 then. So when I start to plug that in, that's pi times 7.5 squared all over 2. If I do 7.5 squared times pi and then divide by 2, I should get the area of the semicircle is 88, we'll call it 0.4. So my total area then is going to be 405 minus 88.4. And I get 316.6. Okay, so that was a little more involved, but don't forget things like the Pythagorean theorem. Okay, the Pythagorean theorem is going to help you find some of these missing pieces. So that finishes our lesson video. Make sure you ask any questions in class if you have them. Otherwise, you should be good to go on the assignment.